So last class we have discussed this point. What is the general format of ordinary differential equation? That is f of the y equal to g of x. This is the general form of the ordinary differential equation. When then g of x is 0, then it is a homogeneous. When g of x is the function of x, it may be the algebraic or trigonometric or logarithmic function, whatever it may be, then it is a non-homogeneous equation. So what are the types? Few types are there for the non-homogeneous equation. Let me see that what are the non-linear. You know what is called the linear differential equation. Homogeneous, non-homogeneous is different. Linear, non-linear is different. What is called the non-linear ordinary differential equation? Write the definition for this. A non-linear ODE is that it is not linear. So when it is a linear, we should know. Then only we can know that part when it is not, when it is a non-linear. See that the conditions are given here. If the coefficients of y, y dash, y double dash, y power n contains the dependent variable y, it is one important point. The last class I mentioned that in case y, the coefficient of y, y dash, y double dash, y power n is multiple with only function of x, it is a linear differential equation. If it is multiple with that dependent variable y, then it is called the non-linear. Just wait, somebody call me. Madam, சொல்லுங்க மேடம். அது பார்த்துட்டேன் மேடம். பார்த்துட்டேன். சரிங்க மேடம், நான் பார்க்குறேன் மேடம். கிளாஸ் இப்போ 1 to 2. தேங்க்யூ மேடம். Mohanasali madam only called me to upload our attendance. She is asking about the attendance. Uploading our everyday attendance. Did you got the official mail ID?
No, sir.
No, not yet. Okay. Once you get that official mail ID, then every process will be very simple. Fine. So when it is called the non-linear ordinary differential equation, y dash, y double dash, y power n contains the dependent variable y, or its a derivative, or if the powers of y dash, y double dash, y power n, such as y dash, yf, okay, y dash square like that appear in the equation, then the differential equation is non-linear. Also, non-linear function of the dependent variable or its derivative, such as sin y or e power y dash, cannot be appear in linear equation. So in the linear equation, simply we can write as d power n minus 1, d power n minus 2 like that. But in the case, this totally differ. See that for instance, dy by dx equal to ax cube, d square by dx square plus 2 dy by dx plus y equal to 0, and dy by dx plus p of x into y equal to q of x. See here, only dy by dx is there, it is not multiple with y. Here, see that d square by dx square and the dy by dx is there, it is multiple with the constant. It is not multiple with y or sin y like that. And then here also, in case this equation also, you can see that this is the general format. dy by dx plus p of xy equal to q of x. It is a linear differential equation. Whereas, see this equation, it is multiple with y. Y into dy by dx plus sin x equal to 0 is the non-linear differential equation. It is the main concept of linear and non-linear differential equation. These few examples are there for this. Y double dash plus 2x cube y dash plus 7xy plus x square is a second order linear ODE. Since see that y double dash, y dash and y, it is not multiple with y. Any function of y is there. Therefore, it is a linear ODE. Here also we can see that y double dash plus y dash equal to root x is a second order linear ODE. In case if it is root y is there, in case if root y is there, then it is a non-linear ODE. Non-linear ODE. See y square plus y dash plus root x is there. Y double dash is different, y square is different. Okay, don't confuse with that y dash and y square. If they are writing that square in the bracket, that means 2 in the bracket, then it is the derivative. If it is not in the bracket, then you can take this is the square. Y square plus y dash plus root x. Actually, only y is there, then it is a linear. Here, y square is there, therefore it is a non-linear ODE. See that y dash x into sine y is the non-linear ODE. In case instead of sine y, only y is there. Y dash equal to xy is there, then it is the linear ODE. In case if it is a multiple with that transcendental function, sine function or cos function, then it is the linear, non-linear ODE. See that the sixth one, very simple example. Even if it is multiple with the transcendental equation sin x, but y is there is no power of y. Therefore, it is a second order linear ODE. So you should know that what is the difference between when it is a linear, when it is a non-linear ordinary differential equation. Next one is if g of x is 0, already I told now, very simple example. Wait for 1 minute. One student not able to join in the class. I don't know the reason, because the same link only we have to join. Okay, the continuation of the class. Definition: g of x equal to 0 in 1, then the above equation is said to be homogeneous. In case f of d equal to, already explained na, if f of d into y equal to g of x, in case g of x is 0, then it is homogeneous, otherwise it is called the non-homogeneous equation. Okay, see the difference between the linear, non-linear, homogeneous, non-homogeneous equation. See, some remark is there. If y I of x I equal to 1, comma 2 are any two solutions of homogeneous equation. If one homogeneous equation is there, if there are two solutions or any two solutions are there, then that means when it is said to be the solution, when it is said to be the solution. For example, in case one equation is there, x square plus 3x plus 2 equal to 0. It is the equation, second order equation. Actually, what is called the solution cause. Solution mean, usually in the algebraic solution mean roots. When it is said to be the roots, when it is said to be the root. If you are finding one root here, if you are substituting the value in the place of x, if it is equal to 0, then it is said to be the solution or root. Okay. Therefore, when it is said to be that, then in case one equation is there, this is the equation. A n of x y power n of x, a n minus 1 of x y power n minus 1. This is the equation. In this equation, if you are substituting that in the place of y, if you are substituting yi in the place, that solution, that means the equation should satisfy. Then only it is called the solution of the homogeneous equation. So here clearly explained that if yi of x, where I equal to 1 to n are two solutions. In case I equal to 1, I'm not taking 2. Okay. In case y1 of x is said to be the solution. If you substituting y instead of y1, then you will get that an of x, y1 x, yn x, an minus 1 of x, y1 n minus 1 of x, a1 of x, y1 of x, then a0 of x, y1 of x equal to 0. When it is satisfied, then it is called the solution of x. Suppose u of x equal to c1 y1 of x, c2 y2 of x, where c1 and c2 are the arbitrary constant, then it can be easily verified that u of x is also the solution of this equation. So here, thus the first order linear differential equation is written as y dash p of xy equal to f of x. A first order differential equation that cannot be written like this is non-linear. Since y equal to 0 is obvious solution of the homogeneous equation y dash plus p of x into y equal to 0. We call it as a trivial solution. This one only. Important point. When it is set to a trivial solution. When it is said to be the trivial solution. Non-trivial solution, non-trivial means it exists. Non-trivial means exists. If we are not able to write the solution for any one of the equation, that is called the trivial solution. That means we are not able to find the arbitrary constant value. Then it is called the trivial solution. Otherwise, it is called the non-trivial solution. In fact, this is true for general linear homogeneous differential equation as well. In the page, one important thing is what is called the homogeneous, what is called non-homogeneous, and then you have to go through the remarks 1 or 2 times, then only you can understand. Next slide is formation of differential equation. In the formation of differential equation, there are few steps are there, or few methods are there. There are 3 methods we are going to see that. First method is Newton method. Second one is population growth model. Third one is logistic growth model. Model 1 is Newton's law. You know what is the Newton's law? F equal to ma. The force equal to mass into acceleration. know that acceleration is the second order derivative. Acceleration, this A acceleration is second order derivative. That is, in the fluid dynamics, usually in the application of fluid dynamics, maximum of the problems is based on this Newton's law only. F equal to ma formula. According to the Newton's second law of motion, the instantaneous acceleration A of an object with constant mass m is related to force F acting on the object by the equation F equal to ma. In the case of the free fall, an object is released from the height h of t above the ground level, then the Newton's second law is described by the differential equation. So here the force is, how can we write the force? F. F of, so what the force contains? There are three things the force contains. One is time, one more is h of t. H of t means height. Then the rate of change of height with respect to time t. That is a very application in the space science. That application is very much important. So this equation you can note down that m d square h by dt square equal to f of t comma h of t dh by dt. That is the equation as formed based on the Newton's second law of motion, where m is the mass of the object and h is the height above the ground level. Because once he found that the apples fall down from the tree to the earth, then only he identify the gravitational force. So once he identify the gravitational force, then only the science is going. After that, the science is going based on this concept. This is the second order differential equation of unknown height and the function of time t. This type of model is called the Newton's second law of motion. Whatever the problem as written in the format of second order ordinary differential equation, then that problem is based on the Newton's second law of motion. This one is very clear. And then the general format of second law of motion is F equal to ma, where F is the right hand side, this right hand side, left hand side is m is the mass, and this a is the second order derivative. Then we can go to the next slide. One is Newton's law, second one is population growth model. Model 2, population growth model. The population will increase whenever the offspring increase. For instance, let us take rabbits as our population. More number of rabbits yield more number of baby rabbits. As time increases, the population of the rabbit also increases. And then one more thing is that there are two things are there. One is when increasing in birth rate, then you have to consider about the death rate also. There are two things are there. One is increasing, one more is decreasing. So when the birth rate is increasing, then the population also will be decreased due to that death rate. So when you go for the mathematical modeling, lot of constraints are there. You have to consider all the constraints when you are forming the mathematical model for the particular problem. So you should know when you go for the mathematical model, you should know all the characteristics of the variables. What are the variables are there? What are the independent variables are there? What are the dependent variables are there? All the things you have to make sure. Then only you can form the mathematical model for the particular problem. Even it is a very interesting subject for forming the mathematical model. Even if you're taking that some cholera problem or some HIV problem is there in the biological. A lot of biological problems are there. So it is very simple. When you go for the project, then if you go that fluid dynamics problems are that based on the biological problems, it is fully based on that the ordinary differential equation. And then it is a real-time problem. That is the one important thing is nothing you have to imagine. From the real-time problem only, you are forming all the mathematical modeling. So the population will increase whenever the offspring increase. For instance, let us take rabbits as our population. More number of rabbits is number of babies rabbits. As time increases, the population of rabbits increase. In the rate of growth of biomass n of t. So to take the biomass n of t of the population at time t is proportional to the biomass of the population, then the differential equation governing the population is given by dn by dt equal to r into n, where r is the growth rate. Where r is the growth rate. And then this model also you have to go through that 2 or 3 times, so then only you can understand this concept. And then model 3. These are the few models are there. One is Newton's law, based on Newton's law of motion. Second one is population growth model. Third one is logistic growth model. It's fully based on the economic, it is a business model actually. Logistic growth model. The rate at which a disease is spread. One disease is spread there. And then even in the COVID time, lot of projects have done, and then they are using this model only. This is the spread model. The rate of increasing in number n of people infected. The rate of increase of number n of people infected in a fixed population L is proportional to the product of the number of people infected in the number of people not yet infected. Actually, in the first slide itself, I told when it is proportional to some product of number, then how can you expand? Sorry, how can you express this? Here they are giving some hints. You can see that how they are forming that mathematical model. The rate of L. What is L here? L is that fixed population L. Fixed population L. And then what is N here? N is the rate of increase of the number of people infected. So the number of, what is the meaning of dn by dl? Dn by dl means the rate of change of fixed population L with respect to the increase of the number n. Then it is directionally proportional to the product of the number of people infected. So product of the people infected is n. And then difference between that L minus n and the number of people not yet infected. So this 3 model is very important in that mathematical modeling. But in that ordinary differential equation, we are not discussing these things. We are discussing only how to solve the differential equation. Only thing is what is the origin for this we should know where it comes from. Once they are giving that lot of ordinary differential equation, if anybody asking that what is the how this ordinary differential equation formed, then you should know that the answer for this. That is very important. Even solving the 1,000 problems is not important. The basic concept is important. Whenever you go into write that the date or some exam for that IIT, then you have to ready to answer for this type of problem, this type of question. Next slide is formation of differential equation. Formation of differential equation from geometrical problems. Formation of differential equation from geometrical problems. These are also the basic one, no need to write. Given a family of functions parameterized by some constant, a differential equation can be formed. So now only we are enter into that somewhat syllabus, because y equal to a e power x b e power minus x. You know that what is the solution, how to form the solution for this. Actually, this problem, sorry, this one is given, then you can find this differential equation. But now we are going to see that in case this is given, how to form the differential equation. Already we have studied about that. Once the differential equation is given, how to form the, sorry, how to find the solution for this. Then everybody can do that. But in case that this equation is given, how to form the ODE for the given equation. So this is the procedure to form the differential equation from the geometrical problem. So consider an equation of family of curves. Consider an equation of family of curves. It is a family of curves. It may be the straight line or parabolic or hyperbolic, whatever it may be. In case if you substituting some values to that a and b, different values to the arbitrary constant a and b, you will be getting that the different curves. Usually what is called the family of curves. In case y, you know that y equal to mx plus c is the straight line, equation of straight line. In case if it is a straight line. Here m is the slope. We know that it is m is the slope. If you are substituting different values to m and c, even y equal to mx, no need to take c also. If you take c equal to 0, y equal to mx is there. If you keep on changing that m value, then we can get that different diagram. How? See that if in case m equal to 0, y equal to 0, x-axis. Y equal to 0 is x-axis. In case m equal to 1, m equal to 1 is y equal to x. Anybody, can you tell me what is that y equal to x? 45-degree straight line. In case y equal to 2, y equal to 2 means this one. Y equal to 3, y equal to 4. So equation is the single equation, y equal to mx. When you are giving the different values that arbitrary constant, then you will get that different straight lines. See, if you are containing all the different straight lines, that is called the family of curves. This is called the family of curves. So this is the starting one. Consider an equation of family of curves which contains n arbitrary constants. It contains only one arbitrary constant. It contains two arbitrary constants. In general, I am taking that in case if it is contained that n arbitrary constant, to form the differential equation not containing any of this constant, let us proceed as follows. So differentiate, what is the procedure? It is the procedure to form the differential equation. Differentiate the given equation successively n times and getting n differential equations. Then eliminate n arbitrary constant from n plus 1 equations. What is the first step? From the given equation, we have to differentiate 2 times. You have to differentiate 2 times. If you are differentiate 2 times, what you get? Okay. There also we can, you write the problem. Same problem we can write. Y equal to a e power x plus b e power minus x. Write the problem. Y equal to a e power x plus b e power minus x. Monisha, are you there? Monisha, Mala, am I audible or not?
Audible, sir.
Audible.
Audible. Then respond. I'm calling two names who are not responding. Mala, what is the first order derivative for this? y dash. What is the first order derivative for this? AE power x. Audio problem AE power x minus BE power minus x. Similarly, differentiate one more time. Y double dash. What is y double dash? What is y double dash here? AE power x plus BE power minus x. So see that AE power x plus BE power minus x is y. AE power x plus BE power minus x is y. Therefore, y we can write this as y double dash. I'm writing here. Y double dash equal to y. Y double dash equal to y. So if you take it to the side, y double dash minus y equal to 0. So this is the method to form the differential equation. In case only one arbitrary constant is there, then you will get that differential equation in first order. Please make note down. In case only one, please mute your audio. Mute your audio. In case only one arbitrary constant is there, only one arbitrary constant is there in the problem, then we can the resultant equation in first order. In case two arbitrary constants are there, then the resultant equation is in second order. Similarly, in case n arbitrary constants are there, then the resultant differential equation in nth order. In nth order. This is very important concept. Next one is see that first example. Find the differential equation of family of all straight lines passing through the origin. Okay, note down the problem. Find the differential equation for the family of all straight lines passing through the origin. So here, differential equation is passing through the origin, family of straight line passing through the origin is y equal to mx, where m is the arbitrary constant. Only one arbitrary constant is there. So what is the procedure here? You have to differentiate n times. So one time you are differentiating here, differentiating both sides with respect to x. You will get the dy by dx equal to m. So you are getting the dy by dx equal to m. This is the second equation. Substituting dy, what is our aim? Our aim is to eliminate the arbitrary constant. Our aim is to eliminate the arbitrary constant. So here m is the arbitrary constant. Just how to eliminate here from that y equal to mx, substituting m value here. So what is m value? Y by dx. Substituting here y equal to dy by dx into x. Therefore, this is the required ordinary differential equation. Here given that it is very important now. Observe that the given equation y equal to mx contains only one arbitrary constant, and thus we get the differential equation in order 1. Can I move to the next slide? Anybody is not completed? Can I move to the next slide?
Yes, sir.
Okay, fine. See the second problem. Form the differential equation. There is no need. Very simple problem only. No need to write. Form the differential equation by eliminating the arbitrary constant a and b. So here mentioned a and b are the arbitrary constant. From y equal to a cos x plus b sin x. See the solution. So given that y equal to a cos x plus b sin x, and then differentiating with respect to x first. So dy by dx is minus a sin x plus b cos x. One more time you have to differentiate. Once two arbitrary constants are there, you have to differentiate two times. Only one arbitrary constant is there, differentiate only one time. That is enough. That is the clue for this. So d square by dx square is minus a cos x minus b sin x. If you taking that minus as common, then a cos x plus b sin x is there. What is a cos x b sin x? That is y. Therefore, we can write, if you substituting that a cos x plus b sin x is y, then t square by dx square plus y equal to 0. As I record this differential equation. This is a record differential equation. Third one example is, see that find the differential equation. Find the differential equation of the family of circles passing through the point a comma 0 minus a comma 0. So the circle passing through the point a comma 0 minus a comma 0 has its center on y axis. Has its center on y axis. So here it is minus a comma 0, and then here a comma 0. So there is no other way. Center on y axis. So center on y axis means let 0 comma b. You have to take, let 0 comma b be the center of the circle. So the radius of the circle is square root of a square plus b square. Therefore we can form the equation x square plus center is on 0 comma b now. Therefore, what is the general equation of the circle? X minus a, sorry, this x minus some value, some center value, in case a comma b is the center. X comma a whole square, not this k. Don't confuse with this k. X minus a whole square, I'm writing the general equation. Y minus b whole square equal to r square. It is the general equation of the circle. Therefore, x, and then here the center points of the circle is 0 comma b na. Therefore, a is 0 here, and then y minus b whole square equal to r square. What is r square here? This is r square. Actually, it is r radius. So squaring on both sides, then we will get the square root of square a square plus b square. Therefore, x square plus y minus b whole square equal to a square plus b square. B is an arbitrary constant there. B is an arbitrary constant. A is the simple constant. Don't confuse with the simple constant and arbitrary constant. Arbitrary constant means keep on changing. A simple constant means it is a fixed value. Simple constant means it is a fixed value. So if you are differentiating one time, you will get that 2x to y minus b divided by dx equal to 0. So what is y minus b here? X by divided by dx. So we can find that b value. Substituting b value in this equation. Substituting b value in this equation, we will get that ordinary differential equation. So how to substitute this? See this. So what is b? X square plus x square by dy by dx whole square equal to a square x by dy by dx plus y whole square. So in the place of b, we are substituting this value. If you are substituting this value in the place of b, in this y get cancelled. This y and this y get cancelled, and then the right hand side you have to get dy by dx value. So if you are solving this equation, simplifying this equation, we will get that x square minus y square minus a square dy by dx minus 2xy equal to 0. So here you can ask one question, sir, here also the constant is there. So that is, we have to identify the arbitrary constant in the problem. That is our challenge. So in case if you are taking a and b are that arbitrary constant, two arbitrary constants are there, then your problem will be wrong. In the formation of ordinary differential equation, you will be committing that mistake. Next problem we can see that find the differential equation of family of parabolas y square equal to 4x, where a is the arbitrary constant. In case they are mentioned that a is the arbitrary constant, then we can eliminate that a, particularly a. How to eliminate a here? As per the procedure, you have to differentiate with respect to x on both sides. Then you will get the 2y dy by dx equal to 4a. So a equal to y by 2 dy by dx. So in the place of a, you have to substitute that value. So here you have to substitute the value. Therefore, y square equal to y square equal to 4x into a. A is y by 2 dy by dx. On both sides, y is there, y get cancelled. Therefore, we are getting the resulting equation is dy by dx y by 2x. This is required the differential equation. Next one is find the differential equation of the family of all ellipses having the foci on the x-axis and the center at the origin. It's a very simple problem. Here two arbitrary constants are there. A and B are the arbitrary constants. So the resulting equation in second order differential equation. So once you differentiate one time, you are getting x square by a square plus y square by b square dy by dx equal to 0. If you are differentiating one more time by using UV method, then you will getting that 1 by a square plus 1 by b square by d square by dx square plus dy by dx whole square equal to 0. So 1 by a square, we are able to write that 1 by a square equal to minus 1 by b square y d square by dx square plus dy by dx whole square. Substituting 1 by a square in this equation. Substituting 1 by a square in this equation. So we will get that it's a very long process. Actually, we have to substitute and then reduce. Then only we will get this equation. It seems simple, but the steps are there to get the answer. Then we can go to the next chapter. Solution of ordinary differential equation. Now only we are coming to our syllabus. In the last class, we have discussed the solution of ordinary differential equation for the homogeneous equation. So solution of differential equation is the heading. A solution of differential equation is an expression for the dependent variable in terms of the independent variable which satisfies the differential equation. This definition you can write. What is the solution of ordinary differential equation? Solution of differential equation. The solution of differential equation is an expression for the dependent variable in terms of the independent variable which is satisfying the differential equation. Whatever the differential equation is given, you are finding some solution that should be satisfying. That's why I told in the beginning of the differential equation. So what are the cautions here? Very simple word they are giving. There is no guarantee or warranty. There is no guarantee that the differential equation has a solution. For instance, y dash of x whole square plus y square plus 1 equal to 0 has no solution. Since y dash of x whole square equal to minus y square plus 1, and so y dash of x cannot be real. So in case if you are expanding that square is there, then you are taking the square root on both sides. If already it is minus. Minus 1 can be written as I square. It's an imaginary. For that imaginary, we are not able to write the solution. That is called the trivial solution. When the solution is not exist for the differential equation, that solution is known as the trivial solution. In case you are able to find that solution for the ODE, then that solution is called the non-trivial solution. Also, second point. Second point is also a solution of different equation if exists is not unique. For instance, y equal to e power 2x, y equal to 2e power 2x, y equal to root 8 e power 2x are the solution of same equation. dy by dx minus 2y equal to 0. In fact, y equal to c e power 2x is the solution actually. So, dy by dx minus 2y equal to 0. In general, we can write that y equal to c e power 2x. Y equal to c e power 2x. In case if you substituting different value for c, then we can get the different solution. At the time, the solution of differential equation is not unique. That is one more thing is there. Because d square y by dx square minus y equal to 0, the answer is a e power 2x plus b e power minus 2x. So a and b are the arbitrary constant. We don't know what are the values of a and b are the arbitrary constant. At the time, we have to form the two solutions. One is called the particular, one more is called the complementary function. Particular integral and complementary function. That's it. See, for any one of the non-homogeneous equation, there are two solutions are there. One is complementary function, one more is particular integral. Actually, that one important reason is there to form the complementary function and particular integral. When you go for that any physical problem, physical nature of the problem, there are two states are there. One is steady state, one more is transient state. Bhargavi.
Yes, sir. Yes, sir.
Steady state na transient state
Sir?
na. Steady state को transient state को difference है.
Sir, it was
Steady state
Sir?
को transient state को difference है ना. Anybody? Any other? Jack बोला Galinger.
it was not.
Yes, sir.
Voice break आएगा. Jack बोला Galinger.
Yes, sir.
What is the difference between steady state and transient state?
Sir, cannot hear properly. It's cracking.
Sir,
So not able to hear.
am I audible?
Yes, yes.
What is the difference between steady state and the transient state? What is called the steady state? What is called the transient state? It is a basic one.
No, sir.
Not no. You don't know that. Any other? Any other? What is called the steady state? What is called transient state?
Sir,
Yes.
steady state established after a specific time.
Steady state established
After a specific time.
after a
Transient
specific
state
time.
is between the beginning and the event. Beginning of the
Okay.
event.
Steady state. Hmm. Okay, very good. Correct one. Transient state.
It's a transient state is essential in the time between the beginning of the event and the end. Beginning and the
Okay,
end.
fine. Very good answer. But actually, the steady state means any process, any activity is not dependent on time t. Is not dependent on time t. It's called the steady state. Steady state. Yes, not STUDY. STEADY. STEADY. Steady state. Steady state means any process doesn't change with respect to time. Any process which does not, that means if it is independent of time t, any value which is independent of time t is called a steady state. Transient state. Transient state means the process is keep on change. The process is keep on change with respect to time t. That is called a transient state. That means if in rocket launching, in case the rate of change is same, in case the rocket is flowing in the same speed, 300 kilometer per minute or 400 kilometer per minute, like that, if keep on going in the same speed, then there is no change with respect to time t. That is called the steady state. In case in signal processing, in some frequency will be vary with respect to time t. The signals will be vary with respect to time t. Then it is called the transient state. Transient state. Okay. Therefore, any one of the differential equation, there are two different types of solutions are there. One is based on steady state. One more is based on transient state. One more based on transient state. When it is keep on changing, when it contains that arbitrary constant, then we have to change that arbitrary constant value. Then the solution will be keep on changing. That is called the complementary function. That is called the complementary function. In the particular integral, that work is not there. There is no complementary function. That is the steady state solution. So for any differential equation, we are having two types of the solution. One is called the steady state solution. One more is called the transient state solution. So the transient state solution is called the complementary function. Steady state solution is called the particular integral. It is one more basic concept of the differential solution of the differential equation. Thus, to represent all possible solutions of differential equation, we introduce the notion of general solution of differential equation. So, what is the general solution? What is the particular? Please note down. Note down this point. General solution and particular solution. The solution which contains as many arbitrary constants as the order of the differential equation is called the general solution. In case the given differential equation contains, the given differential equation is of order n, then the resulting equation contains only n arbitrary constants. Then it is called the general solution. What is the remark here? The general solution includes all possible solutions and they typically include arbitrary constants in the case of an ODE or arbitrary functions in the case of PDE. In the case of partial differential equation, the solution contains that arbitrary functions or arbitrary constants. The ordinary differential equation, solution of ordinary differential equation contains arbitrary constants. If you solving that ordinary differential equation, The solution of ordinary differential equation contains only the arbitrary constant. In case if it is a partial differential equation, the solution may contain such arbitrary constant or arbitrary function. Then what is called as a particular solution? Particular solution is that if we give particular value to the arbitrary constant in general solution, if we give the particular value to the arbitrary constant in general solution of differential equation, the resulting solution is called the particular solution. The resulting equation is called the particular solution. So any one of the ordinary differential equation as a solution, that solution is known as the complete solution or the complete integral. Complete solution or complete integral CI. There are two parts are there. One is particular solution or particular integral. Second one is complementary function. There are two things are there. One is particular integral, second one is complementary function. Then addition of both particular integral and complementary function is called the complete integral or complete solution. What is it? 2 o'clock already. So fine. So next class we will discuss that homogeneous and non-homogeneous, all the things in the next class we will discuss. Right now, 21 questions for the first thing. Any other general doubt is there, you can ask. Apart from any other general doubt is there, you can ask. Okay, you can otherwise COVID இருக்கியா? COVID இருக்க. சரி, ஓகே, நீங்க சாரோட கிளாஸுக்கு போலாமா?
Okay, thank you, sir.
ரம்யா இருக்கீங்களா? ரம்யா லாஸ்ட் கிளாஸ் ஆப்ஷன். ரம்யா இல்ல. ரம்யா மட்டும் இல்ல, வேற எல்லாமே வந்து விஜய்
இருக்கேன் சார். இருக்கேன் சார். இருக்கேன் சார்.
விஜய்
இருக்கேன் சார்.
விஜய் எங்கப்பா? இங்க பேரையே காணோம். யுவஸ்ரீ தான் இருக்கு, விஜயே காணோம்.
இருக்கு சார், ஃபர்ஸ்ட்ல விஜய் மேக்ஸ் போட்டுருங்க சார்.
ஓகே சரி,
விஜய் ஃபர்ஸ்ட்ல பேர் போட்டுருங்க சார்.
ஏன் லாஸ்ட் கிளாஸ் ஏன் ஆப்சென்ட் ஆயிட்டமா?
சார் ஃபோன் ஸ்விட்ச் ஆஃப் ஆயிடுச்சு சார்.
சரி, ஓகே. ரம்யா மட்டும் தான் ஆப்சென்ட், வேற எல்லாம் பிரசன்ட். ஓகே, see you in the next class. I will upload the notes in the notes.
Thank you, sir.
Thank you. நீங்க சாரோட கிளாஸுக்கு போயிடுங்க. லேட் ஆயிடுச்சு.
Thank you, sir.
ஓகே சார்.
Thank you, sir.
Thank you very much.